Welcome to the DIY Honda Garage channel. The DTC P2185 refers to a high voltage issue in the engine coolant temperature, ECT sensor 2 circuit. The ECT sensor is crucial for monitoring engine coolant temperature to determine optimal engine performance and efficiency. In a Honda Civic from the years 2016 to 2021, this sensor is usually located near the engine block, often on the cylinder head or intake manifold. When the ECT sensor operates properly, it sends voltage signals to the powertrain control module, PCM, that reflect the coolant temperature. However, if the voltage exceeds the normal operating range of about 4.92 volts, the PCM detects a fault and triggers DTC P2185. This can cause various issues, such as engine overheating or inadequate fuel consumption, as the PCM may adjust engine parameters based on incorrect temperature readings. The primary component affected by DTC P2185 is the ECT sensor 2, which plays an essential role in monitoring the coolant temperature of the engine. This sensor provides the PCM with real-time data that helps in regulating engine performance, fuel economy, and emissions. It's typically situated close to the engine block, often on the cylinder head or intake manifold, ensuring it can accurately measure the coolant temperature as it circulates through the engine. A voltage reading above the normal threshold of 4.92 volts indicates a problem in the ECT sensor circuit, which can lead to incorrect readings. This inaccuracy can result in the engine running inefficiently or even overheating, making timely diagnosis and repair important for vehicle longevity. Several factors could contribute to DTC P2185. First, a faulty ECT sensor 2 could be the direct cause. Internal failure can lead to abnormal voltage outputs. Secondly, there may be an issue with electrical connectors, such as poor connections or loose terminals, affecting signal integrity. This could result in intermittent readings that confuse the PCM. Additionally, wiring problems such as shorts or open circuits in the wiring that connects the ECT sensor 2 to the PCM can cause a high voltage reading due to resistance or disconnections. Understanding these possible causes will help in efficiently troubleshooting the DTC error and ensuring the sensor operates within specified parameters. When DTC P2185 is triggered, various symptoms can arise, indicating an underlying issue. One of the most critical symptoms is engine overheating, as incorrect temperature readings can lead the PCM to miscalculate the required fuel and air mixture, potentially causing an increase in engine temperature. Another noticeable symptom is reduced fuel efficiency. If the engine runs on inaccurate data, it may waste fuel that could be saved with optimized performance. Additionally, drivers will likely see the check engine light illuminate on the dashboard, signaling that there is a problem that requires immediate attention. Recognizing these symptoms can lead to early detection and troubleshooting, potentially avoiding costly repairs and ensuring the vehicle remains in good working condition. In the first troubleshooting step, you should turn the vehicle to the on mode without starting the engine. This allows the vehicle systems to power up and enables you to assess the ECT sensor 2 signal using the Honda Diagnostic System, HDS. Your next task is to check the voltage output from the ECT sensor 2. The threshold should be greater than 4.92 volts. If the voltage exceeds this amount, this indicates that the failure condition has been duplicated, and you should proceed to the next step. However, if the voltage readings do not meet this threshold, it suggests that the system may be operating correctly at that moment, and further investigation into poor connections or loose terminals at the ECT sensor or the powertrain control module (PCM) may be necessary. For the second troubleshooting step, start by turning the vehicle to the off-lock mode to ensure safety while handling electrical components. Next, you'll disconnect the ECT sensor 2, which has a 2P connector. This step is vital to isolate the sensor from the circuit effectively. After disconnection, you will connect terminals A and B within the ECT sensor 2 connector using a jumper wire. Terminal A corresponds to the first terminal in the ECT sensor 2 connector, while terminal B is the second terminal. By doing this, you are simulating a direct connection to check if the circuit functions appropriately. After establishing the jumper connection, turn the vehicle back to the on mode and measure the ECT sensor 2 signal again. It should still read more than 4.92 volts. If this is confirmed, continue to the next step. If not, it may require sensor replacement. Proceeding to step 3, first turn the vehicle to the off-lock mode and remove the jumper wire used in the previous step. This ensures that you can accurately take new measurements without interference from the connection. After that, turn the vehicle back to the on mode, and it's time to measure the voltage between test points 1 and 2. Test point 1 corresponds to ECT sensor 2 connector number 2, and test point 2 connects to a reliable body ground. In this state, the ECT sensor 2 connector must remain disconnected, allowing for an accurate assessment of the circuit. The expected reading should be around 5.0 volts. If this threshold is achieved, you'll move on to the fourth step. If not, further investigations into the wiring or connections may be warranted. In this fourth step of troubleshooting, turn the vehicle to the off-lock mode before proceeding. You'll need to jump the SCS line using the Honda Diagnostic System, HDS, and it's crucial to wait for more than 1 minute to allow for system stabilization. After this wait time, disconnect the PCM connector E, which has 80 pins, to start checking for continuity. Continuity means that an electrical connection exists without interruption. You'll check between test points 1 and 2. Test point 1 is the number 45 terminal on the PCM connector, and test point 2 is ECT sensor 2 connector number 1. Establishing continuity here will indicate that the SG6 wire, which connects the ECT sensor to the PCM, is functioning properly. If continuity is confirmed, further steps like consulting service information or testing with a known good PCM are next. But if not, it will require repair of the SG6 wire. For the fifth and final step in troubleshooting DTC P2185, start again by turning the vehicle to off-lock mode. Similar to the previous step, you'll need to jump the SCS line with the HDS and allow it a waiting period of more than 1 minute. Once you're ready, disconnect the same PCM connector E, 80P, to conduct continuity tests appropriate for the TW2 sensor line. The check will be between the terminal number 54 on the PCM connector and ECT sensor 2 connector number 2. Finding continuity here would validate that the TW2 sensor wire is in good condition. If continuity fails, this indicates an open circuit requiring repairs to the wire connecting the PCM to ECT sensor 2. In either outcome, consulting authorized service information could provide additional guidance for next steps. After completing all troubleshooting steps, it's essential to verify the effectiveness of the repairs made regarding DTC P2185. Start by double-checking all ECT sensor wiring, ensuring that no loose connections or shorts exist. Testing the ECT sensor's functionality is the next step. Using the HDS, confirm that the sensor outputs readings within the normal expected range. especially during changing temperature conditions. Once all checks are satisfactory and any repairs have been completed, clear the DTC from the memory to ensure that it does not influence future diagnostics. Following this, perform a road test to ensure the vehicle operates smoothly under real-world conditions, monitoring for any recurrence of the DTC, making sure the resolved issue stays resolved. Preventative maintenance can significantly reduce the likelihood of encountering DTC P2185 in future. It is advisable to regularly inspect ECT connections to ensure they are tight and free from corrosion or damage. Additionally, monitoring the coolant levels and quality should be a routine practice to safeguard against overheating issues. Keeping the cooling system in top condition prevents strain on the ECT sensor itself. Scheduling routine diagnostic checks can help detect minor issues before they escalate, ensuring the vehicle's optimal performance. By faithfully following these preventive practices, you'll enhance the vehicle's longevity and reliability, thereby minimizing potential breakdowns associated with cooling system failures. In summary, DTC P2185 alerts us to a high-voltage condition in the ECT Sensor 2 circuit, a critical component for reliable engine performance. Thorough troubleshooting steps involving voltage checks, continuity testing, and verifying the integrity of the wiring and connections are necessary for accurate diagnosis and resolution. Understanding the symptoms, causes, and preventive measures can lead to more robust vehicle maintenance and reliability. Regular inspections and proactive measures ensure that when issues arise, they are addressed before leading to severe complications. Awareness of DTC P2185 and its implications is essential for any Honda Civic owner aiming to maintain peak operational efficiency while avoiding costly repairs. Please like and subscribe to the channel. See you next time.